Hi, this is my Reverb box. I just made this over about the last month. It's this here. Inside it I've got a AT XMEGA 64D3. I've got 512K RAM, although I'm not using nearly all of it. I've got an ADC and a DAC. The ADC is internal to the Atmega, but the DAC is external. And I've got some analog stuff to just do the signal processing to get the signal in and out of it, and some power supply stuff. I've got the power supply coming in on this umbilical cord here. I've got 5 to 10 volts in, I've got signal in, signal out, and in this case I also have some stuff on the breadboard here to do volume control and to get a signal in. I've got a signal in here from the theremin right now, which you can probably not really hear all that well on the phone, but it's just kind of low droning right now. And it goes out to line in on the PC, which in turn goes out to speakers. So I've got that all hooked up. You can see right now I've got the menu looking at some of the reverb tap settings. I'll just show how this works. You can go all the way up, you can go left. Of course, going left on the main menu doesn't go back anywhere. So you got main, you can look at presets, you can look at the preset menu. This goes through EEPROM. You see there's nothing special here. These are all just default values, the freeze. You can see there's two that I've written so far. Right now this is just on tunnel. So there's that. I can hit load. You can see it loads in the parameters. It was already loaded in, doesn't really mean anything. So this has got one tap right now, which means it's only using these values. Delay of 4,000 means 4,000 bytes is 2,000 samples delay at 25,000 samples per second. And the gain of 100 is out of 127. That's also signed, so if I want to change the sign, I can change the sign, and then I can just edit digits if I like to edit digits. A total gain over all the taps of more than 127 or so causes feedback and it builds up and sounds terrible, so you want to modify all of these if you're turning them on. You don't want them to be too high. And then further down we've got filter coefficients, which goes into a digital biquad filter. It's enabled right now. Just turn it on and off. You can kind of hear a pop as it turns on and off. And this is just set for a kind of a narrowband resonator filter thing. Hence the tunnel name. It's kind of like, sounds like being in a tunnel. So I'll give this a, I'm not going to try to play anything, but I'll give the antenna some movement and you can see how it sounds. You can maybe see there's not much frequency response at low frequencies because it rolls off pretty aggressively below, I don't know, 200 hertz or something. It rolls off a bit at high frequencies as well, but not very sharply. I think that's just something that biquads don't do very well. You see it's got kind of a lot of flutter. It's got that kind of sound with the reverb because it's just got the one tap. If I turn on, let's see, I need to turn on 2 taps now, which consumes too much CPU power, so I can't actually turn them both on at once. Let me see. That cleared it. I kind of have to do this through the serial console now because the serial console is driven by interrupts and the LCD just kind of freezes up. But it's running. Let's see. Change. Let's say I do. Let's see, that was 100. Let's say I do half of that. And then. What was. Can't even see it. Okay. do like 1200. And let's do the same gain, I guess. Okay, now I can get it to scroll. Yeah, so you see those both say 50. That's 4,000 and 4,608. I could do a different value there, but whatever. Anyways, it's got a less tail to it because the total gain, I guess, is lower. The two values are kind of close together, so you can kind of hear that. That. Let's say 1700. Oh. Let's see what that does. That's much longer. See, that's got a longer delay to it. All right. I'm going to turn off the filter now. So this is just going to be straight through, and it's got reverb, and it's got full gain at all frequencies. I mean, aside from what the reverb itself is doing. So first of all, you see, also let me show that here. First of all, you see that there's a lot more low frequency gain. So I just turned this off and through the serial console. So you get real low, deep bass notes. And you got the full range there. One downside is you hear how it kind of has this high frequency din to the reverb. That's because you expect there to be losses at high frequency, and that's what I wanted to put the filter in there for. And if you don't have it enabled, it just sounds very unnatural. I can also turn up the distortion on this to be a bit louder. That's good. So now it's got some character to it, but you can hear the reflections better. If I go up here and turn on some more taps and set them in interesting values, let's turn them all on. That high-pitched whine is starting to climb. I think the gain is a little too high. Let's set these to, let's go some crazy values. I'll put in like 15 there. And that can be, I don't know, 20. That's too much again. Like I said, the sum of these has got to be fairly modest. So like if there's 120 divided by 4 is 30 on each. Let's be evenly weighted. And you see the way this is I have to go right into a parameter, and then I can press up and down to edit the value. And that's just a integer, so it wraps around to 65,000. Or if it's signed, these are unsigned values, but the filter values are signed, and I can have that. It wraps around just the same. Let's say 5,000 even. Wait, what was the first one again? 3, 5, 10, 15. Yeah, that should be pretty chunky. Let's get this going. So those are all 20, 30, 30, 30. It's got kind of a saw sound to that high-pitched, yeah. Again, it needs to have the filter enabled to fix that. Let me turn this up and see what happens when I get a little too much gain. I think it's already getting a little too much high frequency gain. Yeah, it's just a little much. I'm not sure if I can turn on a filter here. Yeah, it still runs. I have almost no free CPU cycles, so the display doesn't respond. I can just barely get some serial out of it. This is still with the narrowband filter. I don't remember offhand what the parameters are. Let me... Road number 1. There we go. So that's just doing... I just loaded free. So this is just a default value. It's got 1 tap, it's got some parameters, and the filter's off. And the filter's also at a default value. It's like a shelving filter or something, so it's just got a little bit of high frequency attenuation. Let me set these back. Let's do like 40, 30. It's probably a little too much. Yeah. And then, like, let's even try 1000 and see how that sounds. And then 3, and like 10, make it a geometric series. And, I don't know, 16 something. That's all 4. Yeah. So it's got a pretty good delay there, and if I keep turning this up, okay, I can crank that to, that's like over a second there. So it's really distant kind of a sound there. And if I turn the filter back on, that should be a little more tamed now. Yeah, that high-pitched whine went away. You don't have that high-pitched ringing kind of a sound either. So it's pretty nice. It's a good start. Still needs some more work on the assembly routines. I want to try to save a few more CPU cycles. I want to fix the display hanging up. Right now the problem is that the display is gated by bus activity, because I don't want to be corrupting the LCD with RAM data or vice versa. So there's some priority in there, but obviously it just makes this thing hang if it's not able to get priority. So, some things to do. The platform itself is just not really powerful enough to do a proper reverb stack, so it doesn't sound as good as it could, but given the amount of power that it has, it's not too bad. It's pretty impressive to do this, I think, even as it is. So, hope you enjoyed. Thanks for watching.